So, we go to the next part, magnetic properties. Magnetic properties in solids is due to what? Spinning electrons. Each spinning electrons behave like a tiny magnets and creates a magnetic field around. If you see this diagram, you will realize electron spinning. The spinning electron. Do not see that red marker pen ink, just see about that spinning electron. The spinning electron produces magnetic field in a specific direction. So, that yellow color line has been shown as a magnetic field produced by that spinning electrons. Electron spins around itself and produces a magnetic field. Each electron which is spinning and also revolving around the nucleus produces a magnetic field. Many a times this electrons magnetic fields are arranged in such a manner that they almost cancel each other. So, many a times this magnetic fields cancel each other and the net magnetic field is found to be 0. What you are able to see is again a nucleus made up of a proton and neutron, and these are the 2 electrons of the first shell. They spin in different direction, that we are already aware of Pauli exclusion principle, and the net magnetic field for them is in such a direction that they cancel each other and net magnetic field is found to be 0. Now, in any case, if the electron spin is not cancelled, then if any one electron's magnetic field is not cancelled, spin is not cancelled, then it exhibits magnetism. But if every electron's magnetic spin is cancelled, then it shows no magnetic property. So, to show magnetism, the spin should be unbalanced, at least of one electron. Now, based on magnetic properties, substances are mainly of 3 main types. They are diamagnetic, paramagnetic and ferromagnetic. In diamagnetic, all the electrons are paired, that means their spins are cancelled, that means net magnetic field is 0. Then such substances do not get attracted towards magnet, on the other hand they get repelled. Many examples around us are diamagnetic in the nature. Nitrogen with total number of electrons paired, fluorine with all the electrons paired, NaCl with all the electrons paired, they are all found to be diamagnetic. What are paramagnetic substances? Some electron ka spin remains unbalanced or is not completely cancelled, then such substances are weakly attracted towards magnet or magnetic field. Example, O2, oxygen, which was explained as a paramagnetic in 11th standard under molecular orbital theory. Copper 2 plus with 3d9 is 1 electron non cancelled. Fe3 plus also has 3d5 uncancelled electron. Similarly, chromium 3 plus also has some uncancelled unbalanced electron spins, therefore shows paramagnetic nature. Substances which contain large number of unpaired electrons are shown to be strongly attracted towards magnet, then such substances are called as ferromagnetic. In the world, number of ferromagnetic substances are very few, and in your syllabus you have only 5, and all these 5 examples have to be by hearted by the student. So, remember Fe, Co, Ni, which are transition metals, gadolinium, lanthanide and CrO2. These are the 5 examples which are ferromagnetic, which are strongly attracted towards magnet, and they themselves also can be converted to magnet. You have to by heart this 5 examples of ferromagnetic substances. Now, if you see MnO, where Mn has oxidation state of +2, you know Mn has 3d5, 4s2. So, if you go to Mn plus 2, it has 3d5, and if you draw a box diagram for 3d5, you will find it has large number of unpaired electron. When it is large number of unpaired electron, is expected to be highly ferromagnetic, but was found to be diamagnetic. Now, for us this is a surprise. We expect to have right? So many number of unpaired electrons, and we expect it to be ferromagnetic. What was observed in the nature was diamagnetic. What is the reason? So reason is given by a concept of domains. Now what is a domain? Domain is cluster of various atoms with a similar type of spins. These are different atoms which spins in same direction. Well, this is another domain with electrons having spins in same direction. This is another domain with different direction spins. So this is domain 1, domain 2, domain 3. Every atom has a net magnetic field, but all these atoms have net magnetic field in one direction. So all these magnetic fields are considered to be one cluster, and that cluster is known as domain. While this is considered to be another domain, because all these magnetic spins and directions are different, and this is another domain, domain 3. Are you understanding it? There can be many domains. Now we come to a concept of domains. Only domain concept can help us understand further types of magnetic properties. So magnetic substances are further 3 types based on domain concepts. So we use domain concept to understand that. Here all the electrons are unpaired, or there are many electrons unpaired. Many electrons unpaired. When many electrons are unpaired, they are expected to be ferromagnetic, and observation is also ferromagnetic. Such substances are called as ferromagnetic substances. This 5 examples I said it before also, you have to by heart. Ferrimagnetic substances also have large number of unpaired electrons. So what is expected from them? Ferromagnetic. But what was observed from them? Paramagnetic. What do you mean by they are expected from them? Ferromagnetic and observed paramagnetic, or expected large magnetic movement, they can be converted to magnet. This was what was expected, but was observed was they were weakly attracted towards magnet, and they cannot be converted to magnet. Such substances are called as ferrimagnetic. You can remember the word ferri. Ferri means less. Example is this magnetite. Fe3O4 is called as magnetite, and this are popularly called as ferrites. So magnetite and ferrites are ferrimagnetic substances. This also contains large number of unpaired electrons. So what is expected from them? Ferromagnetic. What is observed? Unusual diamagnetic. And example is MnO. Now why like this? In this all domains or major domains are in one direction. When major domains or all the domains are in one direction, it will have large magnetic properties and will be ferromagnetic. If domains, one domain and another domain cancel, one domain another domain cancel, one domain another domain cancel, then all the domains are cancelled. So net magnetic field on a whole is diamagnetism. If certain domains only cancel and net magnetic field exists, only certain domains are cancelled, then such substances are paramagnetic, and as a whole the substances are called as ferrimagnetism. So this entire concept is explained by domains, which will be again taken in physics under the chapter of magnetism. If you want to see a domain diagram, these are domain diagrams. Remember, it is not a d orbital, it is not a p orbital, it has been shown as domains. This all domains are in same direction. That means such a substance is ferromagnetic. Example, iron, cobalt, nickel, gadolinium, CrO2. What you are able to realize, domains are cancelling each other. Right, if domains are cancelling each other, then substances are anti-ferromagnetic as per NCERT. There is only one example. In ferrimagnetism, remember ferrimagnetism, right, there is certain cancellation and net there is overall net is present. Such substances are called as ferrimagnetism. Example, Fe3O4, ZnFe2O4, MgFe2O4, those are examples of ferrimagnetic. In paramagnetism also there are few unpaired electrons, while in all this there are large number of unpaired electrons, while this has few number of unpaired electrons. Paramagnetic example: oxygen, copper 2 plus, chromium 3 plus, Fe3 plus, they are example of paramagnetic substances. How to identify magnetic nature as a student for our MCQ purpose? By heart ferromagnetic substances, by heart anti-ferromagnetic substance of syllabus. Only one example is there, MNO. By heart ferrimagnetic substance of our syllabus, Fe3O4, and you remember ferrites, ZnFe2O4, MgFe2O4, these are examples of ferrimagnetic substances. By heart this 5 example, as per NCERT by heart only 1, then by heart this example, they are all ferrimagnetic substances. After you by hearted as step number 1, go to step number 2. Remaining all substances are other than ferromagnetic. Other than ferromagnetic, that means they can be either dia or they can be paramagnetic substances. Under that, first category, molecular species or polyatomic species. When I say molecular species or polyatomic species, that means they are made up of 2 or more atoms. In this case, count total number of electrons. If total number of electron is odd, they are paramagnetic. If total number of electrons are even, then they are diamagnetic. Example is B2O2 and S2, where B2 has 10 electrons, S2 has 16, and sulfur 2 has 32 electrons. So remember, B2O2 and S2 are paramagnetic. Remaining all substances are diamagnetic. I say it again. You should first check whether it is a polymolecular species made up of 2 or more atoms. If it is made up of 2 or more atoms like H2 minus, N2 plus, then count total number of electrons. If total number of electrons are odd, then it is definitely paramagnetic. Example, H2 minus, total number of electrons are 3, so it is definitely paramagnetic. N2 plus, total number of electrons are 13, that means it is definitely paramagnetic. But if total number of electrons like H2O is 10, then it is diamagnetic. If you see carbon monoxide made up of 6 plus 8, 14 electrons, then it is definitely paramagnetic, because total number of electrons are even, and for even number of electron to be paramagnetic, there are only 3 examples which are unusual, explained by molecular orbital theory, B2O2 and S2. Now, if you are dealing with monoatomic species made up of only one atom, they can be atom or an ion, then write electronic configuration. While writing electronic configuration, if they have one or more unpaired electron, then they are paramagnetic. If they have no unpaired electron, then they are diamagnetic. We don't have any exceptional case in this case, so they are all diamagnetic. If you check water, total water, first thing, it is polyatomic species. If it is a polyatomic species, count total number of electron. If you count total number of electron, it is 10. Total number of electrons are even, therefore it is diamagnetic. Here in this case, count total number of electron. Nitrogen has 7, hydrogen has 4, minus 1 because it has lost 1 electron due to positive charge. Total number of electrons are even because it is polyatomic species, therefore it is dash in nature, diamagnetic. Similarly, this is also a polyatomic species, and if you count total number of electron, it is even, therefore diamagnetic. If you see another example, Cl plus, it is a monoatomic species. If it is a monoatomic species, then write down its electronic configuration as per this rule. If you write down electronic configuration, it has how many electrons? 16 electrons. 1s2, 2s2, 2p6, 3s2, 3p4, 3p4, that means it has unpaired electron, therefore it is dash in nature. paramagnetic in the nature. What you should have realized, if it is a monoatomic species, write electronic configuration. If it is a polyatomic species, just simply count total number of electrons and you will be able to decide whether the substance is diamagnetic or paramagnetic in the nature. So, we come to the discussion of this chapter called as solid state. So, that was all the discussion related to theory of